continue our work with solving linear equations. In this section, we will take a look at solving equations that have fractions or decimals. We could make things more difficult for us and work with these fractions, or we could clear the denominators and work with integers. Of course, we're going to clear the denominators. Ask yourself what the smallest number is that all of the denominators will divide evenly into. What you're looking for is the least common multiple of the denominators. This is the same number you would use if you wanted to get a common denominator. This is kind of a magic number since it is the smallest number that will allow us to cancel off all of the denominators. As long as we multiply every term by 12, we will have an equivalent equation. Since we are trying to cancel off the denominators, start by dividing the denominator into that least common multiple. Multiply this result by the numerator that's already there. So first term, 2 goes into 12 6 times. 6 will get multiplied by the 5x. Second term, 3 goes into 12 4 times. Third, nothing cancels. We'll get 12x. Last 4 goes into 12 3 times. Now look at how simpler the equation is. This equation will give you the same solution as the original one with the fractions. Again, I move the smaller variable to the larger, then constant the opposite direction. Leave your final answer in fraction form since this is generally the exact form of the answer. So if 7/18 is converted to a decimal, you will find that it goes on forever. So to take it off the calculator, you will be forced to round and therefore approximating your answer. If we clear fractions, we can clear decimals. What is the most number of decimal places you see for all these terms? You see 1, 2, 1, and in the last term 1 decimal place. If you wanted to clear the decimals, we would need a power of 10 with 2 zeros, or multiply by 100. Multiplying by 100 will create a decimal point shift of 2 places in each one of these terms. Check out the decimal point shift in all the terms. This is a much easier equation to work with. Solving with our usual steps, again, I move the smaller variable to the larger and then move the constant the opposite direction. Let's move on to the special cases. This equation starts off with a true statement. X plus 2 already equals x plus 2. With the same expression on either side, this would mean it wouldn't matter what gets put in for x. Every time we would get the same number on either side. That says everything works, or the solutions are all real numbers. Let's go through our algebraic process to see what happens in cases where the solutions are all real numbers. We get to the point where the variable drops out and a true statement results. We get 2 equals 2, but understand it can be any true statement. Understand that when the variable drops out, we have a special case. And then if a true statement results, that says that there are infinitely many solutions, as we reasoned out earlier. And again, we state all real numbers for our answer. Here is our next special case. Notice how this equation starts off false. With the same number of x's on either side and then different constants, it is not going to matter what you put in for x. You will never get the same number on either side. This means we have an equation with no solution. Let's go on to solve algebraically to see what occurs in this case. So here the variable drops out with a false statement resulting. This would say, as we reasoned out earlier, that there is no solution to this equation. So in summary, there are 3 different cases when it comes to solving linear equations. We will either have a unique solution, no solution, or infinitely many solutions. We will find nothing outside of these 3 cases when it comes to solving linear equations. So in this lesson, we continued solving linear equations, working with the more difficult situations with fractions and decimals. We were also made aware of the other special cases where we have no solution or infinitely many solutions. Hopefully, this has been helpful. Thank you.